Okay, this problem is similar to one that's in your book on page 616, number 3. So basically you have a train that leaves the station, so as soon as you see it's talking about miles per hour, trains, things like that, you know it's distance, rate, time. So make a 2x3 grid. Again, usually it makes sense to label one slow and fast so you can keep track of them. And so it sounds like there's one kind of the tortoise and the hare deal where one leaves going this direction and they're kind of slow. Another one leaves later but they're faster, and so eventually they're going to meet. So I know one of them, the slow one, is at 72. I know the fast one goes 120. And again, in a perfect world, this would be that easy, but you know this is false because the fast one's going to go a larger distance or take less time or whatever. So we got to figure out what's the same, what's different. It says, let's see, 3 hours later. So if you read right here, 3 hours later. So obviously the time cannot be the same because obviously it left 3 hours later. And then down here it talks about they travel the same direction. When will this train overtake the other? So if they're overtaking, the distance is actually the same. It's the time that's the problem, right? And so if you look at this, who is going to be on the track 3 hours longer? Well, the fast one is kind of like the hare. They're waiting, they're sleeping, they're taking a nap, they're eating snacks, then they're going to take off fast and get there. It's the slow one that starts off at the beginning and goes very slowly down the track that's going to take more time. So they're the ones that get the 3 hours. All right, so once you have your chart filled out, you can get your equations. Again, distance equals rate times time. So here's my distance, and it equals this rate. And again, you need parentheses times that time. And then you have this distance equals rate times time. And again, this one's perfect as far as I'm concerned for substitution, because if these two guys are equal and that one's equal, then I can just sub in for those two. So if A equals B equals C, then these guys have to be the same. So I'm just going to sub in this guy for that one. Do the distributive property. Let's see, what is that? 216. Let's see, I'm going to subtract my 72. Let's see, what is that? Is that 48? 48, and 48, and I'm going to grab my calculator here quick. Right, and it looks like I get 4.5. Now again, make sure you answer the question because it might ask at what distance, but it says when. When will this train overtake? So when is a time question. So the fast one will take 4.5 hours to overtake. Now, if I asked for how long has the slow car or train been on the track, I'd have to take 4.5, add 3, so 7.5 hours is how long the slow car's been on the track. If I wanted to know the distance that it took, how much distance they had traveled before it happened, I could take my 4.5, sub it in there, and take it times 120. So that would be 540 miles. So as long as I know this, I can sub in the chart and answer other questions.